RC Jim, and today I want to share with you about programming the V-Good ESC with the little programming card that they've got. This is an A32 V4.0 program card put out by V-Good, and I'm going to be showing you how I use this with their 100 amp ESC. It's a great low-cost way to get a very high-capacity ESC. Jury is still out as to how well it lasts and all of that type of thing, but we're going to give it a go. And in the meantime, it's amazing at the number of parameters that they've got on their program card that you can adjust with this particular ESC and program card. So let's show you what it's all about. Well, those of you that watched our video on the Hangar9 Red Tail P-51 restoration and looking at the motor and the prop selection, would have seen this rig that we set up for that. This is our motor that we're going to be using on with that, and we've worked out which prop to have based on our testing with a little rig here. But what I want to show you now is how to go about programming the ESC with the V-Good programming card. Now this ESC that we're working with is a V-Good. That's Shenzhen V-Good RC Technology Company Limited are the guys that put it out, however you're supposed to pronounce that. But that's a 100 amp ESC that we got in here, and that costs about 30 bucks Australian, you know. And actually they're selling it for about 30 something in America too. I don't understand how it is that an American dollar is worth so much more than an Australian dollar, and yet you can buy things less expensive here in Australia. But hey, you know, for all you Yanks, come over here. It's worthwhile. Come on down. But anyway, with the V-Good card, all we got to do, first off, we're going to power the thing up, and let's just take off the prop. So I'm standing next to this thing, and there we go. Okay, so we're nice and safe. So being nice and safe, we're going to go ahead and plug her in. We don't have any signal coming on, so it'll complain about that. But we don't particularly care. All we want to do is plug this in. So that that little complaint is saying that there's no throttle signal. So we're going to plug our cable from the ESC into this side. Got negative to the left there, so that's the brown one. So we're going to put that over there. Okay, so now I got it plugged in and it's happy. So you've got the various items that you can change listed down on the left hand side, and then the lights across the top tell you which items are selected. Okay, so right now, and it's very hard to read these things. Of course, me with glasses doesn't help any. I'm better without them. But with a bright light, it's very hard to read it. So I always put my finger just over it and actually can read it better. So that says cutoff mode and battery type. So the cutoff mode is on slowdown as the default. And of course, with the cutoff mode, it's saying that if it's got down to the minimum voltage and for safety's sake, it needs to cut the power. How is it going to do it? Is it just going to immediately cut the power to the motor while it maintains power to the receiver? Or is it going to gradually make the, not gradually, is it going to immediately reduce the power to the motor to where it's really obvious that something has happened, but the motor's going to keep going in a limp home sort of mode while it maintains power to the receiver to give you a little bit better chance of landing it. Okay, so slow down is a good one. So it's either off, slow down, or cut off. So slow down is obviously what you want there. LiPo is a battery type, so that's obviously what we want. Now to move down to the next item on the list, we just simply press this button at the bottom. And by the way, with the buttons on the bottom, you've got 3 buttons, and then you got the thing that says USB, which is actually just telling you that there's a USB port under there. So the 3 buttons are what we use to control it. USB is if you have this plugged into a computer. They do have software that I haven't been able to find, that I have seen demonstrated on YouTube, where you have this plugged into the ESC, you plug this into your computer, and you can make these changes on the computer. You've also got the possibility of plugging it in over here and upgrading the software on the ESC, whatever they call that, firmware on the ESC. Okay, so we're down to the next one, and the next one is cutoff voltage. Okay, so the light up here indicates that this is the one, and you've got two different sets of voltage there depending on whether it's a lithium-based battery or a NiCad-based battery. So the bottom one is a lithium, so it's saying 3.2 volts it's going to cut off. So that is when it's going to trigger the slowdown mode, and it's going to say we're all done. Okay, so 3.2, we're happy with that. So we go down to the next one, and that says cells. So you see there's no lights at the top, but you also see that there's actually 2 rows for the cells. So it goes all the way from 2 to 14, and then it's got an auto. So why go manual if you can go auto? So go down to the next one. You see that one's lit up as the default to automatically determine how many cells you have. Now, with a lot of these, the auto function only works for lower amounts of cells, and when you get to the higher ones, then you need to specify the number of cells. I don't know if that's the case with this or not. It doesn't seem to say anything about that, but it doesn't hurt to put it on auto for most of the things that we do anyway. And certainly up to that 8 cells, I'm sure that wouldn't be a problem. Okay, we go down to the next one, and that's the protect temperature. So the default is over here at 140 degrees Celsius. And my thought is, well, hey, let's just be a little bit more conservative and go to 130. And by the way you change these, like that would have been over here on the 140 initially, and I've changed it to 130, and I did that by pressing this button here to get it over to the one that I wanted. So I want 130, so I want it there, and then I press the enter here, and that enters it into the ESC. Okay, we go down to the next one, and that is timing. Now the timing is like spark advance on a car, you know. Basically, with the timing, you know, you put the voltage to the motor, but it takes time for the current to build up, and the magnetic field that's generated by that coil in the motor is dependent upon the current, not what voltage has hit it. So it takes some time for the current to build up, for the magnetism in that coil to build up, to actually pull on the permanent magnet and make the thing go. So by having advanced timing, it's anticipating what's needed to give it the maximum sort of thing. Now generally with the timing, the lowest one that is going to work is going to be the one that is wanted. Okay? Going higher is not going to be helping things any. You want to be as low as you can go with it still operating okay. So if we didn't have this auto on here, we'd be playing around with it to see how low can we go, how low can you go with the timing. But it's got an auto function. So let's just leave it on auto. That's all good. Okay, our next one is the brake and motor direction. So we got 2 things on this line. We got the brake as the first 4 items, and they're colored in white. And then it's got the motor direction, which is kind of a yellow-orangey color, as being a different set of things. So there's actually 2 things to set, and so we got 2 lights up at the top. So right now the brake is off, and that's the way I like it, to just allow it to spin. But you can set it at 25%, 50%, or 100%. With the brake, if you've got, say, a sailplane with a folding prop, you'd definitely like to have the brake on, because when the motor stops, you'd like it not to be spinning around and staying out there. You just want it to fold in and not be getting in the way. So you'd have the brake on. You might also use the brake, or at least a certain amount of brake, if you've got a plane that you do belly landings with. You know, it doesn't have landing gear, you hand launch it, and you're just going to belly it in on the grass. It's less likely that you're going to break a prop if the prop is not spinning. So you might want the brake for that. Other than that, it's good to keep it spinning. One is it looks more scale-like, but the other practical thing is that with the ESC, it doesn't know the position of the motor unless the motor is turning. It's depending upon a signal that's coming back that comes from a permanent magnet going past a coil, creating an electric current in that coil that goes back to the ESC, and it says, hey, this is the position that the motor is in, so it can know which coils to fire up next. So it's going to be more responsive if the thing is spinning. Now, it's not going to be a huge difference, but nonetheless, I think it's a good idea to have it spinning unless you're in one of those other categories, and so that means the brake is off. Then the other part is just the direction. It's normal, reversed, and bidirectional. Okay, so normal is just simply saying it's spinning in the right direction. In this particular case, that was already fine. Reversed, if it's spinning in the wrong direction, you could select that one, or you could just simply swap two of the wires, the leads, going to the motor. That will also reverse it. And bidirectional is if it's set up to be able to use reverse thrust to be able to slow things down. So you've got those choices, and it's really hard to find documentation on this. I think Mike and the blokes over there in China that operate this company, and at least Mike is the guy that I interact with. He doesn't seem to know English all that well. And a lot of their information is in Chinese, even the videos and stuff like that. You kind of have to sort of interpret what's going on. So anyway, as far as how you set up the bidirectional thing with your throttle stick and all of that, or whether you do it on a switch, I don't know about that. Okay, our next one on the list is startup power. So you've got everything from 5% to 30% and then auto with startup power. Now, again, this is one that is a little bit of a question. It's not your normal sort of thing of fast, mid, and slow. The startup is fast, medium, and slow. So that's like how much of a punch it's going to give it, sort of the general feel of it. My guess on the startup power is it's more something that just right instantly when it first starts, if you put your hand in it, how hard is it going to hit your hand? And so they've got it on 5% at the default, so that's probably a good thing. But if anybody does know more about that, let me know. The next thing that we come to on the card is the turn-off delay and beacon delay. On the label, it says turn-off, and that's in white. Beacon is in that yellowy orange, and then delay is in white. Well, interpret that to mean in the white part of it, it's the turn-off delay, and in the orangey yellow part of it, it's the beacon delay. Now, as you look at your choices, first off for the turn-off delay, you got off, 3 seconds, 6 seconds, and always. So if you have that off, what that means is your throttle will act like normal. You pull back on the throttle stick, your engine stops, okay? So there's no delay as far as turning it off. If you have the always one, what happens is you pull down the stick, the throttle goes to an idle speed, similar to if you had a nitro engine, and it will just stay sitting there running at idle speed until you unplug the battery or pull out a kill plug or something like that. And then the 3 second and the 6 second is just the delay in when it would turn off. So if you have it on 6 seconds, you pull the throttle stick down to 0, it'll go to an idle speed. 6 seconds later, if you haven't advanced the throttle, it'll turn it off. If you have advanced the throttle, then it'll start all over again the next time you pull it down. It'll still wait for 6 seconds before it turns off. And of course, the idea with that is to have kind of a scale-like situation where you pull up and everything stays running until a few seconds after the stick has been down all the way. Yeah, nothing wrong with that. Okay, then on the beacon delay, your beacon is something that is supposed to help you if your plane goes down and you're trying to find it. So when there's power to the ESC but not a throttle signal, you'll be getting a beep every second or so. You saw that when we first started this thing up and hooked up the programming card to the ESC. Until I plugged in the throttle cable, there was nothing. So you could have a situation where the plane goes down and it stops receiving a throttle signal, but it's still got power to the ESC. In that case, it'll be giving you a beep. So to have a delay on that means you could choose 5 or 10 minutes before that would start. It's going to take you a while to get out there and whatever. And perhaps you don't want it annoying you at other times when you don't have the throttle hooked up. So you could have that delay on there if you wanted that. Next thing on the menu is labeled as option. And there's actually 3 areas on this. I'm looking to see if there's something above and below option. I can't see anything. But anyway, first off, you got some echo options. You got echo 1, echo 0, echo 1, and echo 2. Okay, echo is for saving power, especially for lower efficiency motor. Can help motor run better and save power. There are 3 grades, echo 0, echo 1, and echo 2. Echo is valid in whole running. The maximum RPM is slightly lower. Interpret that the way you see fit. The middle one is the default, and not knowing which way it goes unless you test it out, I'd say just stick with the default. Well, the next thing that we've got on our menu is freewheeling on and off under this option row. Of course, freewheeling, for those of you that are familiar with ESCs and so forth, generally we're referring to an electrical thing. So it's not that the prop is free to rotate and free to wheel around as in the brake is off, but rather we're talking about something to do with electricity. So in your motor, you've got sets of coils, so that they're arranged in groups of 3. You've got your 3-phase electricity that's alternating between these different inputs. And so you've got current going one way through a coil, then current going another way through a coil, and reversing again, and doing all that sort of thing. And with that, you've got a magnetic flux, magnetism, that's generated by the current going around the coil. Magnetic flux is generated one direction or the other, and then it's got to change directions, and it's continually chopping and changing, going on and off, and things like that. Now, if they just sort of did that without doing anything about it, that motor would just virtually blow up. You'd be trying to reverse electricity at times when it doesn't want to do it. The very fact that there's magnetic flux flowing through the coil is going to try to keep that current flowing through the coil in the same direction, and they'll be fighting it, trying to go the other way. So anyway, they have to dump the current each time that they turn off a coil. Normally the older style of doing that would be by using an electronic component that has resistance in it. And with resistance in the electronic component, it's going to create heat, and it's also going to waste energy. The more recent way of doing it, and which higher end ESCs tend to use, is what they call freewheeling. And that's where they use an FET transistor to turn off the electricity that doesn't involve much resistance. And with it, you don't have that heat generated from the current going through resistance, and it operates more efficiently. Okay, so normally the more efficient type operation would be with freewheeling, and the less efficient one would be non-freewheeling. And I don't know of any negative reason for trying to avoid the freewheeling. If your ESC has it, it seems to me like it's a good thing to use it. So my initial thought with this freewheeling option on the menu is that that's what they'd be talking about with freewheeling. But as you read what they say about it, They say, generally freewheeling on is for application requires fast response and stop. And by the way, I'm reading it exactly as it's written. Freewheeling off is for application requires stop smoothly, naturally. Okay, now if you try to interpret that, I think it would be saying it's like a brake, you know, but we've got a separate item on the menu for the brake, and we got different degrees of braking that we can select. Why would you have two different things that are doing, you know, two different menu options that are doing the same thing? You know, one, you know, more variation, the other just on or off. That doesn't make sense to me. My guess is that it's gotten lost in the translation, and somebody's just thought of mentally what it sounds like with freewheeling, and they've assumed that that's what it is. But my guess is we're talking about the electrical type of freewheeling there. So with that, as we look at our options, you've got the Echo freewheeling on and freewheeling off. Then you've got the throttle auto and the throttle memory. Now, with those two things, it has to do with programming your throttle and how that's going to operate each time you start your transmitter up and fire up the model. Okay, so with the throttle on auto, what it's going to do is each time you turn it on, it's going to check to see that the off, you know, throttle stick down is throttle stick down, and it's going to set wherever you got that throttle stick, it's going to set that as zero throttle. And then for maximum throttle, it's just going to assume that you got a 2,000 millisecond signal coming from the transmitter. And of course, the transmitter is going to be sending out something between 1,000 and 2,000 microseconds for the signal for anything, whether it be the throttle or servo or whatever it might be. And so it's just assuming that the throttle stick is going to do the right thing, and 2,000 is going to be your full throttle setting. So that's the auto. Okay, throttle mem, it means that the ESC throttle range will be the latest stored. And so you do a normal programming of the throttle where, you know, you start out, you have your stick all the way up to maximum throttle, you power up the ESC, you hear some beeps, you pull it down to zero, and that's programmed both the maximum and the minimum throttle positions. And on throttle memory, it's going to remember that and operate in that normal sort of fashion. So throttle mem makes sense to me. Throttle auto, yeah, that's going to be fine as well. The biggest concern for me with throttle auto is if for some reason you didn't have your stick all the way back, then it's going to program the zero throttle to be higher up in the stick position. So things could vary a little bit in terms of where you're pushing your stick, but neither of those are going to be a big deal. Now, let's just say that I do want that throttle memory, because to me that sounds like the normal sort of thing. Latest stick, yeah, beeps twice, push stick back. So that sounds to me like the one that I really want. So we'll now see how we change one of these things where you got multiple things that are selected. And this took me a while to figure it out. Okay, so first off, I'm going to go across to get to that one that I want. Okay, so throttle memory is the one on the end, and that's the row that I want. I'm going to say enter. Now when I do that, you see I've just got the one light lit up, and I can go down and go all the way back to that one again, and it's still just showing the one light. And initially, when I saw that, I thought, what's going on here? I'm losing my other selections. Well, in actual fact, if you unplug it, and then you plug it again, plug it in again, the magic reboot your computer thing, it goes through its thing, and I go down here to the option, and voila! I got all three, and it has changed the one that I selected to be lit up. Okay, so that's totally free. It took me a while to figure that one out. I wrote to the people that I bought it from in America and didn't get a response, and I wrote to Mike in China, And good on you, Mike. He responded, but his response was basically, good on the menu, select what you want. And that was about the extent of it. But anyway, I appreciated the response. It was good to hear back from somebody, at least to try. And if I was to try and respond to him in English for something he asked in Mandarin, you know that there's no way I'd be able to tell him anything sensible. Unless Google Translate can handle that, I'm not sure. Okay, so we got option. Next we got BEC voltage, so that's simple. 5.5 volts is the voltage that the receiver needs, and it could be selected at 6 or 7.4 or 8 if you had something different. Spool up acceleration, okay, and then startup. Okay, so spool up acceleration is 1.1, 1.2, 1.3, and 1.4. That doesn't necessarily mean anything in particular other than 1.4, it's going to spool up quicker than at 1.1. And right now it's set on 1.3, and 1.2 is the default. But then it's got your startup, fast, medium, and slow, and that's on fast. Okay, so go figure as to you know, which one is which and all of that type of thing. Okay, next we've got the PWM frequency, the pulse width modulation frequency. Now keep in mind the ESC is sending out 3 signals in rotation, firing up different pairs of coils going round and round and round. And when you get to partial throttle, what it's doing is it's just sending pulses for each one. Rather than reducing the overall voltage, what it does is it reduces the time that the voltage is applied, and it's cutting them on and off. But it can't go any faster than the pulse width modulation frequency. So the question is, how fast can the motor go? And with those 3 sets of things that are happening in there, what sort of frequency does it need to have as a minimum to be able to make it go? And the way you determine that is you take the kV of the motor, which is 610 for this one. What that means is that it'll turn 610 RPM for every volt of electricity that's applied to it. So take the kV times the voltage. Sometimes they say a nominal voltage, but I reckon it makes more sense to be closer to the top end because you want it to run well when the battery is fully charged as well as when it goes down. And having the pulse width modulation frequency a little bit too high is not going to hurt anything. If it's way too high, then you're just wasting electricity. So you generally want it closer to the lower end of the scale, but a little bit above what it needs to be as a minimum. So take the kV times the voltage times the number of poles in the motor. And for this XM5050, we're talking about 14 poles, and it's talking about how many magnets, how many permanent magnets are around it. So the number of poles, so you got 610 times, I'll call it 24 volts for the 6S battery, times 14 poles. Divide that by 20,000, and that'll give you the PWM minimum frequency in kilohertz. So in this particular case, it works out to 10 kilohertz. Here on the card, the standard is 16 kilohertz. There is one down there at 12. We could use that, but with a default, I think I'm going to just play it safe and, you know, could perhaps run a little bit smoother at this slightly higher frequency. And at least we're not going way up. It could be as high as 32 kilohertz, and that'd just be a waste of energy doing that. So I'm going to leave it at the default. Okay, and the last item there is just a reserve item that they might provide something for in the future. Okay, so that's all there is to it. Once you've gone through and you've done all of that, you just simply unplug the card, and she's all set to go. Well, thank you again for watching one of our videos. It's great to have you watching, and especially for those of you that are subscribing. Thank you so very much. That means an awful lot to me. It's helping me personally, and I hope that I'm helping you. So, hey, it's a win-win solution. So, what you need to do, if you haven't done already, is to click on that little circle with my picture on it and subscribe. Doesn't cost you anything. It means that when you want to find some crazy thing that I'm doing and talking about and teaching, you just go to your list of subscribers, find RC Jim, and you'll see all of the latest there. And then, of course, also have a look at some of our recent videos on the channel, or some of our old ones, whatever. I trust that they're going to be really helpful to you as well. Today, of course, we learned all about this, and let me know what you think. It'd be great to hear your comments. So you have a great day, and happy flying.